Hello and welcome to this presentation of data visualization of the water quality in selected Ghana districts. This visualization is using the D3.js technology, which means it's using D3 and incorporating the JavaScript. It's Solimo Rajab, registration number stated below, who is presenting on this. So much of the video about the data set and the site of acquiring data set plus the processing of data has been actually attached at the last slide of this presentation. So you can review to the last presentation, the last slide, and you view the presentation or the video related to. So this is the landing page of what I have come up with, where I have the D3 visualization by myself, my registration number, where I have on the first line I have the bar chart, which is static D3, and employing the JavaScript. It is visualizing the total hardness and then the calcium hardness, as we shall see some of these graphs in. So plus all these other visualizations that we shall be looking at. What library now? The page which is the first one gives us just the dashboard where we have to learn on, that has the links that takes us to the particular visualizations. In brief, we say that I will say this project of visualization, this is this .js, which has that has been employed here. This is a free open source JavaScript library for data visualizations. It's actually a low-level approach built on the web standards offers, and which offers some unparalleled flexibility in authoring dynamic data-driven graphics. This tree is not a charting library, in the traditional sense. It has no concept of how charts or whatever do happen. But yes, when you visualize data with this tree, you find out that you can compose a variety of primitives. This three most novel concept is it is data join, which means that it is given a set of data and a set of DOM elements. This data join allows you to apply separate operations for entering, updating, and maybe exiting the elements. In these visualizations, there are up to about 7 different visualizations from the dataset that I acquired from the Waterfall website. First, before the actual visualization, the dataset, I had to process it to do away with whatever was missing and maybe some of the duplicate entries, plus whatever could deem necessary for visualization. This has been used alongside with the Java. Now the first visualization is the static D3 bar chart, which gives us the visualization of the total hardness and the calcium hardness. And here you will see that yes, Clamour has the highest total of hardness, and then also the calcium hardness, followed by these other districts of Bujiri, Bujinja, Luwero. This visualization actually is giving us the totals per district, not per village, but this is per district, as you can see at the bottom here. We now find out that the total hardness is usually the sum of the calcium and magnesium concentrations, both expressed as calcium carbonate in milligrams per liter. And then the calcium hardness is a measure of the amount of calcium ions present in the water, which is a description of water has a hard, means that it has a high mineral content. Then this other chart is the animated D3 bar graph, which is visualizing the total alkalinity of still these other selected districts in Uganda. And you'll find that here Lamu here has or still leads with the total of 12,012 total alkalinity, followed by Bujiri, Kayunga, and as it moves up to Mukono. With Kawempe and Luka, these are districts without anything. They have zero of this alkalinity. That's why it is left at plain. So as you can see in this other visualization, which is also a bar chart and it's a star, you see that the Kamwenge and then the Luka have not been visualized yet, because this stack one takes it as if it has no of relevance, it has nothing to do here. So we can still see that Lamu here has given us the highest, Bujiri, Kayunga, as related to the animated previous by chart. Then we also have another one here, which is the pie chart and the donut chart, and you will find out that here with the pie chart here, Lamu has the highest number or the highest total of electrical conductivity, followed by this other district, with Mubende having the lowest of all the districts. Actually, Mubende and Bukwere, those are the two districts that have got the lowest. So with the donut chart also here, we see that it gives us the same visualization as the pie chart. So this one gives us an idea of how and where things are, or how we should maybe be focusing on when in relation to other. So in this other scatter chart, this one visualizes the the pH, the electrical conductivity and ability of the district, and you see that here these districts, some of these districts have got the highest, because it combines all of them. If in the last slide where there is a presentation of the visualization on a web browser, you see that here when you bring your cursor, you move over, it gives you what is the amount of the ecoli, what is the amount of the pH, and what is the amount of turbidity and conductivity plus their measurement. So this is a scatter giving us all that. It's a movable scatter plot. Next is the Choroplex map, which is giving us the longitudes of all the selected district. You can hover over and you see that here it will give you the longitudes and give you everything of the districts, sorry, the villages, or the locations or the longitudes of all the villages within the selected district. So in this other visualization, it's a side-by-side maps, which is comparing the fluoride, the components of fluoride, the phosphate, the sulfate, the nitrates, and then the nitrates. So in this visualization, you find that the one whatever is being shown here is for the phosphate. So if you went to the browser and click on the fluoride, it has to give us also the whatever is composed of fluoride alone up to the nitrates, and it has to be changing. This map has to be changing depending on whatever is selected. Okay, this is a link to the video, the project, which is the GitHub project. Hello, welcome to this presentation about data visualization using this way, library, converting the JavaScript libraries to come up with visualizations. And the visualizations are about the water quality in some of the selected districts in Uganda. The data set for visualization has got from this website of Data, and it is a size of about 891 KB. That's the size of the data set. So this data set has a number of up to 16 districts, and in each district there are variables that were looked at, like there was this team connecting the village, the parish, the sub-county, county, district, and then the geolocation, plus other water components like the pH, the electrical conductivity, stability, and so many other parameters. So if you look at So for better visualization, this data set has to be clean. Each this data set was cleaned or processed to such a data set. This data set can now visualize us, can now give us the village, the district, plus all these other parameters that we can use them for better visualization of the data. In overall, I had, after processing, 178 lines of data for visualization. So going into the visualization, came up with a dashboard that contains links to various visuals that were done or created using the district and the JS libraries. So here is the dashboard that links to each particular visualization within my project. So the first visualization is a pie chart, which is a static one. It gives us the visual about total hardness and total calcium hardness. And here you will see that is the total hardness and calcium hardness is a little much higher in Lamu district compared to other districts. This total hardness and calcium hardness is a summation of whatever is happening per district, and you see that in Lamu it has to about 22,000 plus total hardness. As it comes to Bujiri, Jinja, Luero, Kamuli, and so forth and so forth. So it comes dropping up like that. The visualization shows us at which district has this amount of hardness or total hardness and this amount of calcium hardness. Mubende has the lowest, which is below 1,000 of the total hardness and calcium hardness. The second visualization is an animated visualization, which is giving us the visual of total alkalinity of the same selected district. And you see that in this visualization, Lamu is leading. It has the highest of 12,012 total alkalinity, followed by Bujiri as it moves up to Mukon. Now with Kamwenge and Luka, this district had no such total alkalinity within. That's why the visual here, the chart here, has left it at blank. Next visualization is a static one, also giving us another better version or another version of the total alkalinity of the local district. And you find that Lamu is still at the 12,012, followed by Bujiri as it drops down to Mukono. In this visualization, in this chart, you find out that the Kamwenge and the Luka could not be visualized here because they had no data to be captured. So the graph with its intelligence had to leave it out. Right? So another visualization is the animated pie chart and then the donut chart. In these two charts, it is visualizing electroconductivity of per district, and you find that within the pie chart here, Lamu still has the highest in much of these, even in the electroconductivity. That's what we've seen in the previous charts that it has been having high. And when they has or this has the lowest electrical conductivity within its water. So looking into the donut chart, you see that the donut chart is transferring exactly what is appearing on the pie chart, and you see that the moon is still taking the highest or the biggest portion of the total electrical conductivity among the districts which have been selected. So the next other visualization is coming up with a scatter plot. This scatter plot is visualizing about the equally, the pH, electrical conductivity and stability of the same districts which have been selected. And the pH here, we are measuring the pH using the acidity of using the acidity and the basic water. pH in this scatter ranges from 12 to 247 per district. As you can see in this district here, you see that the pH is 247 acidic, the equally is 0, which means there is no equally registered or captured within this district. Electrical conductivity is 2198, which is Siemens per meter. Okay. Other scatters here tell us that here within this district you will find that there is a pH of 78 acidic and the electron is 106 per 100 meters, no millimeters. Electrical conductivity is also at 4838 S per M. Looking at this other district also, we find that it has this pH, the equally and the electrical conductivity. This chart is a zoomable sort of chart, scatter chart, where you can zoom, you can move around so that you can keep seeing which district are you talking about here. Like this is district of Wakiso. In district of Wakiso, there is a pH recorded of 44.25. Equally is 55 per 100 millimeter, and the electrical conductivity is 1368 centimeters per meter. And in this other district, you find that this is a district of so the next visualization is a geospatial map, which is giving us the longitudes of the villages from the selected district. And you find out that when you go to a particular village, it will, when you move over, it will give you particularly the longitude of that particular village. As you can see, there is warning, and you see that yes, in Google it gives you it is particular longitude as captured in the data set. Lastly is about the side-by-side maps comparing the components of the fluoride, the phosphate, the sulfate, and the nitrate. So this is a map which gives us the vision of all that, and you see that the first visualization of the first map here is about the phosphate speed. And if you wanted to find out about the fluoride, you can go and click on the fluoride button, and you can see that it is giving us the vision of the fluoride within these selected districts that we have been talking about. So the subsequent other presentations or marked presentations shall be captured within or have been captured within the PowerPoint presentation. Thank you for the time.